Waka, waka, waka. All right, y'all. We're still talking about circles and parts of a circle. In this case, we're talking about segments of the circle. Now, this one, in the last one, we talked about the secants and tangents in arc angle measures. Ooh, excuse me. They get a little confusing because they look relatively the same, but we're talking about two completely different parts. Here we're talking about segments, and it's the actual tangent lines and the chords that happen. We're talking about the actual measure right there. All right, let's start with this first one here. So this, again, two lines that intersected inside a circle, not necessarily at the center, they just intersected. So in this case, they're chords. So anytime lines intersect, they get split up into parts. So for example, here, this line, we'll call it line 1 and line 2. They intersected and formed smaller parts. So they didn't get cut in half, and this in half, they got cut into smaller parts. So when that happened, we formed part A and part B of line 1 and part X and part Y. And I just use these letters just to show the difference. Now, the value of so as according to the theorem, if you multiply the individual parts, they will always equal to each other. So it's because it's a ratio thing. Crazy, huh? So here, if I take A times this other part, B, that equals the value of X times this other half over here, Y. So this is where I would pause, let you guys write it down, blah, blah. But, okay, you guys can pause that. All right, so let's kind of try that out here. So here, we're saying, these are line 1, line 2. So 3 times the other half, X, so 3 times X should equal 12 times the other counterpart, 2. Should equal 12 times 2. So let's do that. So 3 times X is 3X. 12 times 2 is 24. Divided by 3. Means the value of X is 8. Is 8. Now that same concept applies over here as well. Let's try this. This one's going to be a little bit of a mess, but let's work through it. So here then we'll do X plus 10. So X plus 10 times X times X. Alright. Should equal 8 plus X. X plus 8 or 8 plus X times this counterpart right here. Let's change colors so don't get these confused. Times its counterpart here, X plus 1. X plus 1. Alright, so here we have distributed. So X times X, X squared, X times 10 plus 10X. Here, X times X, X squared, X times 1, 1X, 8 times X, 8X, and then 8 times 1. Okay, so algebra for you guys right there. You complain that you want some algebra? Well, here you go. Alright, combine like terms, we get X squared plus 9X plus 8. Over here we got X squared plus 10X. So the great thing about having X squared on both sides is when I subtract one to the other side, I'm going to choose squares. Minus X squared minus X squared. Ooh, they cancel each other out. So our problem, which I'm shifting over here, is left with 10X equals 9X plus 8. So then, just like before, gotta get all the x's together, so we can subtract 9x. We're left with x. Over here, we're left with 8. Bam. So, even though they're not the same distance, so for 12, 13, 14. So this is 14 units long, and this, since it's 8, 8, 9, 10, 11 units long. They're not the same length, 14 and 11, but their products, because of proportionality within a circle, are the same. So that helps us find missing parts right there. Alright, so that's lines that intersect inside a circle, okay? And we're not looking at the angles this time, we're looking at the actual lengths of the sides inside the circle. Now let's see what happens when they exist outside as well. So here we're talking about the two secants. Here we called it the segments of chords. Here's secant segments. They're secants because, again, they're like chords where they intersect, but they keep going out. So they have an intersection there and there, but keep going out. Now, the way this one works, the top is the mathematical word saying definition here. Here's a little plain English. What we're going to do is, it is divided into two segments, but we look at the whole thing as a whole. So I use the letter K to represent the whole thing right here, and I use the letter P to represent the whole thing here. These letters will never be used all the time. These are just letters I pick. Okay, so don't get confused. Don't just write this down. But if you're going to write this down, you have to have this picture so you can match what part are we talking about. So for example, here, we're saying if we take the entire secant distance times its outside value, so K times V, that is equal and proportional to the whole other secant times its outside value. Okay, so here we're looking for the value of x, which has nothing to do directly with this whole theorem, but it is part of K. So when we say K in this case, it's x plus 8. Not 8x, but not multiplying, it's x plus 8. So to represent K, here's it. X plus 8 times its outside part, 8, is equal to this whole thing, which we are using P to represent it. In this case, it would be 10 plus 16, oh, 10 plus 16, 10 plus 6 would give us 16, times its outside value. In this case, it's the 6. Alright, so here we'll distribute. We get 8x plus 64 equal, what is that? 36, 6, 7, 8, 9, 96. So we're starting for x, so minus 64, 8x equals 32, divided by 8, x equals, what is that? 4, yeah, sorry, 4. The value of this x is 4. Alright, let's try another one. So again, there's no letters here, so don't stress, don't what's the word, obsess over the K, V, C, P I use. Just remember, it's the entire secant, so in this case, the whole secant, 8 times its outside part, in this case is the x, is equal to the entire secant of the other secant, 12 times its outside part, in this case, 4. So 8 times x is 8x, 12 times 4 is 48. Then we divide by 8. X equals, what is equal, class? I don't know. 6? Yeah, 6. X equals 6. Alright, so this is two secants. Two secant meaning intersects twice in there, so there's a little chord in there, and then it keeps going outside. Now, what happens if we have a secant and a tangent? Crazy, crazy thing. Well, for the secant and a tangent, the idea is very much the same as before. We take the entire secant, the whole thing, times its outside part. That's equal to the tangent times itself. So in this case, we said c times c. So let's fill this in right here. So the secant, the entire secant, will be the 6 plus 2. In this case, it will be 8. Times its outside part, which is 2, is equal to the tangent, in this case is our x, times itself, x. So 8 times 2, 16. 16 equals x squared. So then what do we do, class? Yeah, square root it. We get 4 equals x. Alright, let's try another one. Learn a nice, fun, hard one here. Just for a blast. So again, secant, the entire thing. A lot of people get this confused. X plus 2 plus x is 2x plus 2. 2x plus 2. Times the outside part, which in this case will be x, equals 12 times 12. 12 times 12. So we distribute, we end up getting 2x squared plus 2x equals 144. Now here's the doozy on this one. We're going to make a little quadratic equation, and we're going to factor that. So that means we're going to subtract 144 to both sides. Now this 144 cannot subtract from anything over here on the left, so when we rewrite this, we'll rewrite this as 2x squared plus 2x minus 144 equals 0. So you guys remember from Algebra 1, we learned how to factor out these trinomials. First things first, let's reduce everything. Let's divide everything by 2. Gives ourselves a little bit smaller numbers. In doing so, we got x squared plus x minus, what is that, 72? Yeah, equals 0. So when we factor this, we ask the question, what two things multiply to be x squared? That goes right here and right here. Well, it's x and x. So x times x. You get that. Now, the second question is, what two numbers multiply to be negative 72, but when you add them up, they add up to be the same numbers? Well, think of all numbers that are one number apart from each other. They're multiplied to be 72. 8 and 9, yeah. 8 and 9. But it's a negative 72, that means one of these has to be negative. Now to figure that out is, if we do, let's say we do 8 minus 9, that gives us negative 1, but we need a positive 1. Positive 1. So that means this is the negative, this is the positive right here. Now to figure out what our actual answer is, we're going to take both of these trinomials and set it equal to 0. So x minus 8 equals 0, and x minus or plus 9 equals 0. And we solve for x. So here, plus 8, you get x equals 8. Here, minus 9, you get x equals negative 9. In geometry, you can't have a negative answer. You can't have negative 9 and negative 9 plus 2. That answer for this whole thing will be negative, what is that, negative 16? You can have a negative 16 distance. So our answer would be the plus 8, the positive answer, x equals 8. So 8 plus 2 is 10. All right, y'all? Hope that helps. Oh, and usually people ask, like, what if it's two tangents? Well, we talked about this 2 lessons ago. If it's two tangents, then they're exactly the same distance. There'll be no one distance is the same. All right, y'all. Hope that helps. Take care. Merry, probably post this on Sunday. Merry Sunday. If you watch it on Sunday. If not, hope you enjoy it. Bye.